This video is going to be just a basic argument for a subjective explanation for Occam's razor. I'll describe in a second what this means, but it will be it will show up easier in contrast with objective explanations. So a lot of philosophers of science, philosophy of science related to Occam's razor tends to split into kind of two different directions. The first is that it will be claimed Occam's razor, it's not actually that useful of a heuristic or rule. It's mostly just a pragmatic preference that does not predict the truthfulness of theories. Another strain of thought is just to suggest that there's some kind of objective tendency on the part of the universe to maximize simplicity. It's not hard to see how such a notion could originate. For example, the laws of fundamental physics are things get simpler. Sorry, I'm going to stumble a bit. Things get simpler the more fundamental levels we go to, although this is partially just expected due to the definition of what it means to get more fundamental. Another thing is there's lots of principles of work minimization in physics where, for example, really famous principle of optics is that light always takes the simplest path, and there's tons of this in physics. However, the issue with these objective interpretations of Occam's razor is that they can never ground the level independence of Occam's razor, where Occam's razor appears to apply to all levels of reality at any degree of complexity. So why should, if it's grounded in some physical preference for simplicity, there's very little reason why it should explain, for example, the usefulness in fields like sociology or economics, where we're dealing with these behaviors of conglomerations of trillions and trillions of different fundamental particles. This is a huge issue, and it's paired with another major issue, which is that Occam's razor, if it's due to some preference on the part of the universe for maximal simplicity, then it should be able to shape both ways. In other words, it should be able to help predict phenomena that simpler phenomena will exist, rather than just helping to predict theories. There's no evidence that Occam's razor is anything but a statement about theories. So it's unlikely that it's a representation of any program on the part of the universe to optimize for simplicity, when in fact we can't seemingly predict any of the phenomena based on it, but only compare explanations of that share phenomena. So, yeah. Are there other options for grounding Occam's razor? Well, indeed, there's the potential for subjective explanations of Occam's razor, and I'm going to give what to me is the most interesting one, which is, so this is coming in a framework of viewing theories as acts of information compression. A scientific theory takes an immense amount of data about the universe, and it crushes it into these simpler principles that essentially, just like a file compression, there's a space-time trade-off occurring where, given information about that, for instance, if we had a complete deterministic theory of the universe, this this compression analogy clearly holds, because what we do is we, just like in a file compression where there's a seed and then there's kind of these rules you use to unfold and restore the initial information. If we had the initial state of the universe and then we had all this and a complete set of rules, if we had an adequate amount of computing power, we could reproduce this state. So what a scientific theory is, and this works differently in a setting of non-deterministic physics, where it's a probabilistic compression, but it's an active information compression, essentially. The interesting thing about this is if you look at how information compression works, what it involves is basically we can only compress information to the extent that we detect patterns in the data. The more effective and the more thorough the patterns detected are, the more effective the compression is. And I'm actually claiming, so this is a very interesting perspective on scientific theory formation, because it draws attention to the fact, really important but often underrated, that to create an effective scientific theory, evidence is required. We have to already have spotted these patterns and know things about the universe. It's not just we make a theory and then we get evidence afterwards through experimentation. There's a certain amount of internal evidence and information that's required to even find a theory. And my viewpoint on what Occam's razor actually is it's a demonstration about something, about the process of the knower or discovery that came up with the theory, where we're actually seeing a sign of the amount of internal evidence they found. The more effective and the deeper the patterns spotted are, the more effectively they can compress information. So as a result, they can produce a simpler theory. It's a very unusual notion of how Occam's razor works. Why this heuristic is useful. That it is some sort of transfer of evidence about internal evidence in the mind of the discoverer, but there are actual reasons to believe in it and reasons why it is a useful perspective and why it explains things that objective theories of Occam's razor do not. For example, Einstein famously stated that he did not need to see experiments to know that his theory of relativity was correct. He claimed that the theory was so simple and beautiful that he knew it was true. This is a strange idea, because these are seemingly aesthetic principles, but actually they indicate a lot more than just that. And I'll be making a second video on this, explaining some more of why I believe this, what the implications are. But the super interesting thing is, it's going to give reasons to think that intelligence cannot be reproduced through brute force. There's lots of people claiming if we have enough computing power, it doesn't matter if we have good programs for artificial intelligence, we will just be able to reproduce results of intelligence. And you're going to see actually how that's likely not true, and how in areas of theory formation it could actually be an issue and could result in the production of misleadingly good-looking theories by artificial intelligence. You'll see what it means when you watch the next video.